All right, so here we go. This is the Unit 11 worksheet. This is the one we did in class today, so review 1 we'll call it. Electron travels along a circular path with a radius of 4.6 miles. So we have this circular path. Radius is 4.6 miles. What is the number of miles the electron traveled during an interval when the central angle formed by the path was 220 degrees? So this is our 220 degree path. We're trying to figure out how far it traveled. So this, we're talking about this arc length here. All right, and that's what we're going to have to try to find. Freeze that for a second. All right, so the arc length formula in degrees is the angle over 360 times 2 pi r. And we're just going to plug in. So 220 over 360 times our circumference, which is 2 pi times 4.6. And you can just type this whole thing right in your calculator if you want. If you want to reduce first, you're more than welcome to. All right. So once again, we got 220 over 360. You hit enter. And if you did go to math and then fraction, yours is just going to be, it's going to come out like this, so you have to worry about it. If you do get a decimal, you can hit menu, number, and then convert to fraction, approximate to fraction. So this is 11 over 18, and then we have 2 times 4.6, which is 9.2. So this is essentially 11 over 18 times 9.2 pi. So we can multiply this 11 over 18 times 9.2 with the pi, and we're going to round this out to the nearest tenth when needed, so this is going to be 17.7. And this is miles, okay? All right, number 2. Here we have radian measure. So option number 1, we're going to convert this to radians. So in your calculator, you're going to enter it in like normal, okay? The fraction, so you're going to do the fraction bar and then 4 pi over 3. So 4 pi over 3. Then you're going to go press down to the pi button, okay? So the pi button's going to be down over here. And then you're going to select the R. So it should look like 4 pi over 3 with that little R. Hit enter, and it'll convert it right for you into right into degrees, okay? It should come out to be 240 degrees. And then you can do, that's this once again, and then you can just do the same thing we did. So you're going to 240 over 360, and you're going to multiply through. If you're doing in radians, remember the formula is the angle over 2 pi times, and this is 2 pi r. The 2 pi's are going to cancel, so it's just the angle times the radius. That's it. That's the arc length in terms of radians, okay? So our angle is 4 pi over 3. The radius is half the diameter, so that's 12. If we keep it in terms of pi, we're not going to multiply the pi and the button on the calculator this time. So in terms of pi, it's 4 divided by 3 times 12, which is 16. That's 16 pi. That would be in terms of pi. We want to multiply this out times pi, so it's going to be 50.3. And this is what this is equal to. All right. Okay, and number 3, a dog has a 20-foot leash attached to the corner where a garbage and fence meet, as shown in the accompanying diagram. When the dog pulls the leash tight and walks across the fence to the garage, the arc makes 55.8 feet. So that's the length of this arc. We know that the leash is 20 feet long when she's pulling a taut, so that's the radius. And then all we're going to do is figure out the angle. It's in degrees, so we're going to use our theta over 360 times, and this is the arc length, so 2 pi r, that's our arc length formula, and we just plug in. So we know that the arc length is 55.8 is equal to, don't know theta, over 360 times, and then we're left with 2 pi times the radius, which is 20. So remember, this, it becomes 1. This becomes my numerator, okay, and that's my denominator. So this is 55.8 over 1 is equal to 40 pi theta over 360, and then I just cross multiply. Okay, That's going to be it for that part. So 360 times 55.8 is 20,088 is equal to 40 pi times theta. And then we just divide out by 40 pi. Make sure if you do the division by like this, you do parentheses around that. And then we know that theta is going to equal 159 point. And this is 9 because the next number up to the e to the 5. All right, number 4 is shown in the accompanying diagram. Dial in the shape of a semicircle has a radius of 4 centimeters. Find the measure of theta in radians when the pointer rotates to form an arc whose length is 1.38 centimeters. So, same thing. It's in radians this time. So remember the formula is angle. If you want to use theta again, go for it, or just x, okay, over 2 pi times arc length. So 2 pi r, okay, that's our formula. The 2 pi's cancel. So arc length is equal to the angle, which we don't know, times the radius, right? And then we can plug in. So 1.38 is equal to x times 4. Divide by 4, and you'll have your answer. All right? So we just do 1.38 divided by 4, and that's 0.345 is equal to x pi. Okay? That's it. Now, if you did it in degrees to convert to radians on your calculator, all you're going to do, let's see if we can get this loaded. This is going to be interesting. It'll be one of those things where I shine it at the computer screen and it looks like it's like going crazy. But we'll finish up 5 and then I'll go to converting to degrees and radians on the calculator. All right, we have a circle. The central angle is 90 degrees, so it's coming down like this. It intercepts an arc whose length is 3 pi over 2 centimeters. Okay. How many centimeters are in the radius of the circle? So same thing, we're in degrees. So the arc length is just the angle, we'll call it theta, over 360 times 2 pi r. And I just plug in. The 3 pi over 2 goes in for the arc length. This is equal to, 90 over 360 times 2 pi, and I don't know what the radius is. So this is going to come down to 1/4, okay? So it's 3 pi over 2 times, and then it's 1/4, or equal, sorry, and then 2 pi r. Now the 2 pi r is going to go to the numerator when we multiply, okay? So 3 pi over 2 is equal to 2 pi r over 4. You can cross multiply, so 12 pi is going to equal 4 pi times the radius. We divide by 4 pi, and you're going to get 3 is equal to r. All right, and that's going to be the answer here. Okay, we're going to try this, so we'll see how this works. All right, I have no idea if you guys are looking at the right screen, but welcome to my daughter's room, by the way. Horses galore, little sock monster here. All right, I'm assuming this is working. It's upside down, so I don't know how to flip this over. Can we flip this over? We'll invert the camera. All right. So we get this right. All right. Yeah, this isn't going to work. All right, I'll try to do another video later if I can get batteries for my calculator here. So I'll try that later. I'll send out a little special video. Hope you enjoy the room here. This is the decorations and the kind of crazy video. So that's the first part of the worksheet. The second one you already have, and then I'm sending the next one out in a minute here.